This is going to be, mostly review. So first of all, we're going to talk about functions, but we're going to compare and contrast functions and relations. Before we talk about functions, we want to talk about relations in math. Give me 1 to 5 on your comfort with the term relation in math. And it might be low. I mean, I don't know. I really don't know. How comfortable, how confident do you feel that you understand what a relation is? Okay, we're all over the board. Okay, good. Anybody want to throw out an idea? What's a relation mean? And we'll build on that. Don't be shy. This doesn't have to be a 100% right answer. We just want to have a starting place here. What do we mean by a relation in math? Any idea? And the title is descriptive. Relationship between 2 points. Okay, close. We're on the right track. It is a relationship. So a relation is a way of relating inputs and outputs. That's all it is. It's some kind of an organized way to relate input values and output values. So usually that would mean, get those Chromebooks all the way closed. So usually that would mean X coordinates and Y coordinates. It doesn't have to though. I mean, that's just the most comfortable, convenient way for us to think about it because we're used to graphing things in the XY plane. But we could do things like in physics a lot of times our input variable wouldn't be X, it'd be T. We want to look at things like calculating velocity as an output by inputting values of T. So it could be time and velocity, it could be all kinds of things. But it's easiest for us because we're talking about the XY plane. Well, usually we're graphing relations and functions in the XY plane, so we'll just defer back to X and Y. So that's all it is, a way of relating inputs and outputs. What are the ways we can do that? So a set of ordered pairs. It could be shown in the form of a set. We could have sets of inputs and sets of outputs, for example. That's one way we could describe the relation between, and we'll look at these examples, between inputs and outputs. It could be, we could visualize or explore the relationship between inputs and outputs using a table. We'll use tables like t-tables, right? T-tables are one way to show us the relationship between input values and output values. It could be a graph. We use graphs a lot. A graph is a really detailed way, visual way of showing us relationships between inputs and outputs. Or it could be a mapping, right? It could be a mapping. What's a mapping? Well, you may not have ever seen that. We'll look at some examples today. You'll see when we get there. Or it could be an equation, right? Probably the most common way for us in algebra is with an equation. So the set of X values in a relation, what do we call that? The set of all the input values. Usually X values, but not always. But the set of all input values is what? Starts with a D. The set of all the possible input values for a relation. All the X values we can plug in. I think you guys know this, I really do. It starts with a D. Okay, dependent and independent. That's not what I'm looking for, but we'll get there too. Dependent and independent are different ways of describing input and output. So I like the idea, but that's not what I'm referring to. Domain. Okay, is that ringing a bell? Right? Domain goes with X or Y. X, right? Those are the inputs, right? So you're used to probably thinking about it as the set of all X values, which it is, but it doesn't have to be X values. It's the set of all the input values. That's the domain. Oh, so now you're going to know this other one too. The set of all the output values is what? Range. There you go. Good. Okay. A relation that there's two different kinds of graphs we're going to see here too. We're going to see graphs that I would draw by putting my pen on the board and graphing some shape without picking my pen off the board. And there are relations where I could graph individual points corresponding to ordered pairs, where I have to pick my pen off the board every time I want to move to another input and output ordered pair. If they're distinct separate points, we describe that as being discrete. Okay, if it's just individual points that are not connected. If all the points are connected with smooth lines or curves, you know what we call that? This is one of our big topics we're talking about in calculus right now. So we go into much more detail with these things later. That is continuous. It's a continuous relation if I can draw it without picking my pen off the board. The board is my pen is in contact with the board continuously. Okay, so that's a relation. Relations are very broad. Anytime there's some connection between inputs and outputs, that's a relation. Now, what about a function? A function is more specific. Functions are special types of relations, so they're a subset of the set of all relations. All functions are relations, but not all relations are functions. What has to be true about the relationship between the inputs and outputs for a relation to graduate to the point of being a function? What do you remember about functions? And it's probably been a while, because I'm sure you didn't talk about this last year. This would have been a couple years ago. What about functions? For every input value, what has to be true for the output? For every input, there is exactly how many outputs? One. That's the key. That's what determines whether a relation is a function or not. For every input value, there has to be exactly one output value. Okay? Each input has exactly one. If an input has multiple outputs, could it be a function? No, can't be. So for example, if I input a value of x equals 3, and I got output values of 5 and 8, it can't be a function. That's a relation, but not a function. Okay, so here's an example of a set of ordered pairs. Okay? Why is that a function, but this is not? Okay, because in the red relation, look, there's 1, 2, 3, 4 ordered pairs, and notice that 2 of those ordered pairs have the same input. It's equal, 1 is my x input, but my y output could either be a 9 or a 12. So that's a problem. This is why the red relation, that set of points, does not correspond to a function, but the green one does. Because look, in the green one, each input only has one output. If you were looking at a bunch of examples of this, can you determine what's a really easy way to spot, really simple, to spot whether a set of ordered pairs is a function or not? What happened over here that allowed me to pretty easily see that it's not a function? I had the x value 1 showed up multiple times, right? Anytime the input shows up more than once in a set of ordered pairs, it's disqualified, right? Because that means I'm going to have multiple outputs for that input, okay? What does that correspond to in terms of graphs? You guys remember the vertical line test? Give me 1 to 5 on the vertical line test. Okay, this stuff's, okay, so this is good, we're reviewing this. I wasn't sure how much we needed to review this. So can you tell me why this is a function? And this is where we'll stop today. And we'll review this a little bit more on Monday too. That's a function, but that's not. How come? Yeah, the vertical line test it really is just a way of testing whether we're meeting this, this rule applies. For every input, there's one output. Look at this function right here. Each x value only has one y value because there's never a place where the function overlaps vertically, but that's not the case here. If I pick an x value, let's just hypothetically say that that's the x value 2. Well, look, when I input a 2, I get 2 different ordered pairs with the x value 2 because they line up vertically, right? Because they line up vertically, those points have to have the same x coordinate. And so our vertical line test just says, if I sweep a vertical line across a graph, if it ever intersects the graph in more than one place, then it fails the vertical line test and it's not a function. Okay, give me 1 to 5 on that. Is that making sense? Give me 1 to 5 on all this stuff today. I just kind of need to know where we are. Is this ringing a bell? Coming back? I mean, it's been a while, but it's making sense? Okay, we're going to stop there. I'll put this assignment up just in case you want to start on it, but I won't make it due until like Tuesday of next week, 'cause I want to, or Wednesday. I want to finish this up on Monday.